Welcome to today's lesson. I'm Siamasaka Krenden, so I'm going to take you through a lesson where we'll actually look at how we can calculate acceleration using a ticker tape timer. And so we go straight into the lesson. Well, here we note that we can see actually a ticker tape which has dots in it, which were formed as a result of an object which was moving. And we note that the motion of the object is shown that is in that direction, and that the dots closer to where these arrows are, where actually you are pulling the tape, they are close to each other, meaning that the object at the starting point, it was moving slowly, and therefore the dots are close to each other. And so eventually at the end here of the tape, you notice that where the final velocity is, the dots are far apart, meaning that the object was moving faster. So we note that this is actually a representation of a uniform acceleration, because from the equation, acceleration is equal to final velocity minus initial velocity. We find that actually the final velocity shows that an object was moving faster than the initial velocity, and you divide by time. But to actually know how to calculate time, as per now, we are merely representing a uniform accelerating object. So at times, an accelerating object can be shown through actually a graph. So I'm going to represent a graph here where the y-axis actually will have the length in centimeters, and the x-axis actually will have the ticks. And so an accelerating object, we are going to represent, for example, this bar shows that these actually were the dots. And then another one, 3 of them actually in each graph. Another one. So this one actually shows, for example, if this was 2, then this is 4, and this is 6. It shows that actually the initial velocity for this object, which will be the initial velocity will be this one here, and the final velocity will be that one. So we notice that actually this object was moving with uniform acceleration. It was moving with uniform acceleration because this is actually a straight line in that direction. So this represents actually using a graph, a body which is actually accelerating uniformly using a ticker tape timer. So now we have to look at also a board represented on a ticker tape, which is decelerating. And the motion, again, of the object, of the tape actually, is moving in that direction. And you notice that here, the dots are far apart, and eventually they become close to each other. what it means that our initial velocity will have actually an object which is moving faster. Why are we saying it's moving faster? Because actually the dots are far apart. And then the final velocity we see that actually the object was moving slowly. Why do we so? Because the dots are close to each other. Here, we notice that the dots are close to each other. And so when we calculate actual acceleration, which is equal to final velocity minus initial velocity over time, we notice that actually the initial velocity is going to be actually greater than the final velocity. And therefore, we're going to find negative acceleration, which is actually deceleration. So an object which is moving in uniform deceleration can be shown on a ticker tape timer where actually the dots are far apart and eventually they become closer to each other. Similarly, we can represent the uniform acceleration, deceleration using a graph. We can say actually x-axis, we have the ticks, and the y-axis, we have the length, which is say in centimeters. And so you notice that actually, for example, if you have 3 dots, which are actually evenly distributed, but they are decreasing. So this one becomes our initial velocity, and that one becomes our final velocity. And so you note that actually this object here is moving with the uniform deceleration. So this is a presentation of an object actually moving with the uniform deceleration. For example, we can say if this is 2, that is 4, and that is 6. Okay, so this graph shows an object which is moving with the uniform deceleration. And so the time taken during an acceleration or deceleration is actually the time taken from the initial velocity to the final velocity. So in other words, what we are saying is that if you have your ticker tape timer and you have your initial velocity there and you have your final velocity there, so this time it will take for it to move from the initial velocity to final velocity is what is known as actually the time taken from the initial velocity to the final velocity. In other words, when you are calculating time, actually, you have to find the time is actually the time taken by an object from initial velocity to final velocity, which we have presented by V, and then this one was presented by U. So that is the time taken actually by the ticker tape time. When you're calculating time, it should be the time taken by an object from the initial velocity to the final velocity. And so now we have a question here. A car moving reduces the speed after seeing a person crossing the road if the ticker tape timer makes 50 dots per second. Find the acceleration of the car represented below. The first thing to know is that actually, if they say 50 dots per second is the same as actually 50 hertz. This is very important because this is the frequency. And we note that per each tick, one tick, therefore, on a ticker tape timer, one tick will be equal to 1 divided by 50, which is actually 0.02 seconds. So this is very important. We know that actually there are 50 dots per second, which are being made by the ticker tape timer, which is actually equivalent to 50 hertz if you are to actually to use frequency. And it means that one tick, because we said one dot, if it is vibrating, one dot, the dot, the distance between the adjacent dots is actually what is known as a tick. And it's represented actually, we are saying here, it's represented by 0.02 seconds. And so here we have this diagram, which they have indicated here. Well, it's important to know that the direction of the motion is in that direction. And so it means that our initial velocity will be this one here, initial velocity. And our final velocity will be that one here. So we note that actually the initial velocity, the dots are far apart, meaning that time the object was moving very fast, while the final velocity, it is actually the dots are closer to each other, meaning that the object wasn't moving as fast as it was moving at the initial velocity. And so the first thing we are supposed to do actually is to calculate the initial velocity. As you may be aware, the initial velocity is equal to actually displacement divided by time. And in our case, the displacement is 4 centimeters. And our time per tick, because there is only one tick meaning that the time between these two adjacent dots, so which is actually 0.02 seconds, which gives us actually 200 centimeters per second. And then we need also to find now the final velocity, which is V, final velocity. The final velocity will be equal to displacement over time. And we note that our final velocity here is 0.5 centimeters. 0.5 centimeters divided by the time for one tick there, which is 0.02 seconds. And actually it gives us 25 centimeters per second. So what we need now to find is to find the number of ticks. So that we are able actually to find the time between, if we know the number of ticks, then we can now find the time between actually the initial velocity to the final velocity. And you notice that here, actually we have the complete ticks. We have 1 here, then 2, and 3. So since this is the initial velocity, and this is the final velocity, so you notice that here we will get half the tick, and this side half the tick, which actually gives us 0.5 for each of them. So we are going to have the number of ticks we are going to have 0.5 plus 3 plus 0.5, which gives us actually 4 ticks, because the initial velocity and the final velocity have only 1 tick for each of them, and we are taking the middle of the initial velocity and the final velocity. So therefore, you are going to get half the tick for the final velocity and half the tick for the initial velocity. And therefore, as we indicated, this is actually final velocity, and then this is the initial velocity. And therefore, what we are going to find is that we have 4 ticks. And so the time from initial velocity to final velocity, it will be equal to actually 4 ticks multiplied by 0.02 seconds, which gives us 0.08 seconds. So we have known now the time. And therefore, for us to calculate acceleration, we're going to say acceleration is equal to final velocity minus initial velocity over time. which gives us our final velocity was actually 25 centimeters per second, 25 centimeters per second. 25 centimeters per second minus the initial velocity, we found 200 centimeters per second, divided by the time, which we got as 0.08 seconds. And therefore our acceleration then becomes minus 2187.5 centimeter per square seconds. So today we have known and we have gone through how to calculate actually acceleration on a ticker tape timer. So those who want one-on-one lesson, you can contact me on my WhatsApp number, which is +260 977 419949, where I can actually give other several examples on a ticker tape timer and many other lessons, and you benefit greatly. I thank you.